So good morning, everyone. So today we're going to discuss about design and implementation. So design and implementation are the key stages in the development systems, the projects, programs, or strategies in various fields. No. So when we say design, of course, it refers to the planning and creation process where objectives, requirements, and constraints are considered to produce a conceptual framework or blueprint for a system development or product development or solution to a problem. There are certain key elements. Of course, the analysis of requirements, conceptualization, specification, planning, and user experience. When it comes to implementation, of course, implementation is the process of executing the design plan to build a deploy the system, product, or solution in a real-world setting. So the key elements includes execution, integration, testing, deployment, and monitoring. And to give us more details about the topic, let us all welcome our presenter. Go ahead. No sound, no sound, no sound.
In this chapter, we will explore the software development phase where the executable software system is built. We'll cover essential design principles, patterns, best practices for coding, and the role of code reviews and testing. This chapter will provide a comprehensive guide for understanding how design and implementation are interlinked in software engineering. This slide covers key software design principles and common patterns used in software development. The Standard Responsibility Principles ensures each class has only one responsibility. The open-close principle dictates that software entities should be open for extension but closed for modification. The Liskov substitution principle states that objects should be replaceable instances as their subtypes without altering the correctness of the pregase, interfulsmilchos entulzatis tungchov. This slide covers key software design principles and common patterns used in software development. The Standard Responsibility Principles ensures each class has only one responsibility. The open-close principle dictates that software entities should be open for extension but closed for modification. The Liskov substitution principle states that objects should be replaceable instances as their subtypes without altering the correctness of the pregase, interfulsmilchos entulzatis tungchov. Next, we have design patterns. Types of design patterns number 1. Creational patterns like singleton and factory focus on object creation mechanisms. Number 2. Structural patterns such as adapter and composite are about class and object composition. Number 3. Behavior pattern like observer and strategy are concerned with object interaction and communication. Writing code following best practice. Writing code following best practice. Firstly, coding standards should be followed consistently. For example, naming conventions should be uniform throughout the code base, and the code should be dry, meaning don't repeat yourself. This reduces redundancy and increases code reusability. Next, we should write modular code by breaking it down into smaller, reusable components, making it easier to maintain and test. Documentation is also essential. Using standards like Javadoc helps maintain a clear understanding of each component's purpose and usage. Additionally, it's important to avoid magic numbers by using named constants and to keep methods concise to minimize complexity. Error handling and logging should also be implemented to ensure the code behaves as expected during runtime. Firstly, code reviews and testing are integral to the implementation process. Firstly, code reviews involve peer reviews where developers check each other's work to find bugs, improve code quality, and ensure adherence to coding standards. It's a continuous feedback process that enhances both the design and the implementation phases. When it comes to testing, we employ several strategies. Unit testing targets individual components to verify their functionality. Integration testing assesses the behavior of combined components to ensure they work well together. Automated testing integrates with continuous integration, CSUM, ensuring that tests run automatically every time new code is committed, helping maintain stability in the codebase. When it comes learn software design principles and patterns. Introduction, whether you're a beginner or an experienced developer, understanding these concepts is essential for building scalable, maintainable, and efficient software. Today, we'll cover some fundamental design principles and explore key design patterns that can enhance your coding skills. Learn why software design matters. Why should we care about software design? Good design leads to code that's easier to read, test, and maintain. It helps us build systems that are flexible, scalable, and resilient to change. On the other hand, poor design can result in code that is difficult to understand and modify, often referred to as spaghetti code. Our goal is to avoid this by following proven design principles and patterns. Why software design? Let's begin with some core software design principles. These principles provide a foundation for creating high-quality software. Solid principle. Single responsibility principle, SARP. A class should have one and only one reason to change. Open-closed principle. Software entities should be open for extension but closed for modification. Interface segregation principle. EIs should not be forced to depend on methods they do not use. Dependency inversion principle. Deep, high-level modules should not depend on low-level modules. Both should depend on abstractions. Understanding design patterns. Number 1, creational patterns. These deal with object creation mechanisms aiming to create objects in a manner suitable for the situation. Example: singleton, factory method, abstract factory. Number 2, structural patterns. These focus on class and object composition to form larger structures. Examples: adapter, decorator, composite. Number 3, behavioral patterns. These patterns deal with object interaction and responsibility. Examples: observer, strategy, command. Understand a deeper dive into key patterns. Singleton pattern ensures a class has only one instance and provides a global access point. It's commonly used for logging, configuration settings, or connection pool. Factory method pattern provides a way to create objects without specifying the exact class of the object that will be created. It promotes loose coupling and enhances flexibility. Observer pattern establishes a one-to-many relationship between objects. When the state of one object changes, all its dependents are notified. This pattern is widely used in event handling systems. A deeper dive into key patterns. While design patterns are powerful, it's important to know when and how to use them. Overusing patterns can lead to complexity. Here are some tips. When and how to apply patterns. Start simple and apply patterns only when they solve specific problems. Understand the problem thoroughly before choosing a pattern. Don't force patterns into your design. Let the problem guide you. Design patterns are like tools in a toolbox. The key is knowing which tool to use in which situation. While the role of code reviews and testing, following design principles and applying patterns is just part of the equation. Code reviews and testing are crucial practices that complement these efforts. Code reviews. They ensure that design principles are followed and patterns are applied correctly. They also provide opportunities for learning and improvement. Testing. Automated tests, including unit and integration tests, help verify that the software behaves as expected and meets design requirements. Testing early and often minimizes bugs and helps maintain code quality. Combining principles, patterns, reviews, and tests will lead to better software development practices. The role of write code following best practices and coding standards. Writing clean, maintainable, and efficient code is essential for building successful software. By adhering to best practices and standards, we ensure that our code is consistent, readable, and scalable. Why are coding standards and best practices so important? They provide a shared understanding and structure for writing code, which leads to several benefits. Consistency. Standards ensure that code looks and behaves uniformly across a project, making it easier for teams to collaborate. Readability. Clean and consistent code is easier to read and understand, making it simpler to maintain and extend. Quality and maintainability. Adhering to best practices reduces bugs, improves performance, and makes code easier to refactor in the future. The future. Onboarding new developers. When code follows a standard, new developers can quickly understand and contribute without learning individual coding styles. Why are following coding standards? Number 1, indentation and spacing. Consistent indentation and spacing improve code readability. Follow your team's or language-specific guidelines. Egg 2 or 4 spaces per indent. Number 2. Brace style and placement. Whether you use Ullman or Kier style, consistency matters. Make sure all developers follow the same style in the project. Number 3. Naming conventions. Use consistent naming conventions such as camel case for variables and functions and Pascal case for classes. This consistency helps others quickly understand the purpose of different code elements. Number 4, error handling. Always handle errors gracefully, avoid silent failures, and provide meaningful error messages or logging. Follow writing testable codes is a critical part of coding best practices. Testable code allows you to verify that your software works as expected and prevents bugs from going unnoticed. Here's how to make your code more testable. Write small, independent functions. Functions that focus on a single task are easier to test individually. Use dependency injection. Avoid hard-coding dependencies inside classes or functions. Inject them instead, which makes it easier to mock these dependencies during testing. Separate business logic from UI. Keep the business logic in separate modules or layers, making it easier to test without involving the user interface. Write unit and integration tests. Ensure you have automated tests in place to verify that your code works as expected and integrates well with other components. Write version control best practices is an integral part of modern software development, and following best practices ensures a smooth workflow. Commit frequently. Commit your code often with meaningful commit messages. This helps keep track of changes and makes it easier to find bugs. Use branches. Use feature branches for new features or bug fixes. This keeps the main branch stable and allows for parallel developments. Code reviews. Regularly review code changes before merging. Code reviews help catch potential issues, enforce coding standards, and facilitate knowledge sharing within the team. Version Code reviews and collaboration are essential for maintaining code quality and consistency across a team. They provide an opportunity to learn from each other and ensure adherence to best practices. Focus on code quality, not style. Ensure the review process is constructive and focuses on the logic, efficiency, and clarity of the code, rather than just stylistic choices. Establish a review process. Set clear guidelines for how code reviews should be conducted, including timeframes and criteria for approval. Encourage open communication. Use code reviews as an opportunity for learning and collaboration. Encourage team members to ask questions and provide constructive feedback. Understand the importance of code reviews and testing during implementation. These two practices are critical for maintaining code quality, ensuring functionality, and building reliable software. In this session, we'll explore why code reviews and testing are so important, the benefits they provide, and how they fit into the software development process. Understand why code reviews and testing matters. Code quality. Both practices help maintain high code quality by identifying bugs, improving code structure, and ensuring adherence to coding standards. Knowledge sharing. Code reviews foster collaboration and knowledge sharing within the team, making it easier for developers to learn from each other. Prevent bugs early. Testing ensures that code functions as expected and catches issues early in the development cycle, saving time and resources. Maintainability. These practices make code more readable and maintainable, which is crucial for scaling software and onboarding new developers. Why the code review process? Submit code for review. After completing a task, a developer submits their code via a pull request or merge request. Review by peers. Other developers review the code for issues related to logic, structure, and adherence to coding standards. They provide feedback and suggest changes if needed. Make revisions. The original developer addresses feedback, makes necessary changes, and resubmits the code. Approval and merge. Once the code meets quality standards, it is approved and merged into the main code base. The code benefits of code reviews: improve code quality. Reviews catch bugs and logical errors that may have been overlooked during development. Consistency. They help enforce coding standards and best practices, leading to a consistent code base. Knowledge sharing. Developers learn from each other's coding styles and techniques, which enhances overall team skills. Reduce technical debt. By identifying potential issues early, code reviews help minimize technical debt and make the code base easier to maintain in the long term. Testing during implementation. The two main types of tests are: number one, unit testing. These tests check individual functions or components in isolation. Unit tests ensure that each part of the code works correctly on its own. Number two, integration testing. These tests verify that different components work together as expected. Integration tests help identify issues that arise when parts of the code base interact. Automated testing and its benefits is an essential practice in modern software development. It involves using tools to automatically run tests as part of the development process. Benefits of automated testing include: number one, feed. Automated tests can run quickly and frequently, allowing developers to catch issues immediately. Number two, consistency. They provide consistent and repeatable results, ensuring that code changes do not introduce new bugs. Number three, regression testing. Automated tests can be reused to verify that new changes do not break existing functionality, which is critical for maintaining a stable code base. Number four, continuous integration. Automated testing is integral to C pipelines, where tests are run every time code is pushed, ensuring the code remains functional at all stages of development. Combining code reviews and testing for best results. While code reviews and testing are effective on their own, combining these practices leads to even better results. Here's how they complement each other. Number one, reviews enhance testing. Code reviews ensure that tests are properly written and cover the necessary scenarios. Reviewers can also suggest additional test cases that might have been missed. Number two, testing supports reviews. Automated tests give reviewers confidence that the code works as expected, freeing them to focus on code structure and design instead of functionality alone. Number three, higher quality code. When both practices are implemented together, they create multiple layers of defense against bugs and issues, resulting in a more robust and maintainable code base. Best practices for code reviews and testing. To make the most of code reviews and testing, here are some best practices. Number one, keep reviews small and focused. Review code in small chunks to maintain focus and reduce the time needed for feedback. Number two, write meaningful tests. Ensure tests are meaningful and cover different edge cases. Avoid writing tests that only check the obvious or expected paths. Number 3, use automation tools. Integrate code review and testing tools like GitHub, Bitbucket, and automated testing frameworks, Aggie-Just, Janit, or PyTest into your development workflow. Number 4, encourage collaboration. Foster a collaborative culture where feedback is constructive and viewed as an opportunity for learning and improvement. Conclusion. To conclude, understanding software design principles, patterns, and best practices is essential for developing high-quality software. The design and implementation phases are closely intertwined, and successful software development relies on continuous improvement through code reviews and testing. These practices not only help maintain the integrity of the code, but also ensure that the software meets the user's requirements effectively. Thank you. Conclusion.
Okay, so you're done. Okay, so there are certain relationship between design and implementation. Sequential process specifically, no? And again, the design comes first, no, as it lays the foundation for implementation. And the interdependency which flows in the design can lead to issues during implementation, requiring iterative process and goal alignment. Both phases aim to address an initial problem effectively and efficiently. So if this applies, no, to a specific context, no, software, infrastructure, curriculum, and others, we could able to discuss on how we will be able to use this design and implementation for software engineering specifically. Again, in the design, specifically for software engineering, this will be to create, no, a detailed blueprint for the software system, ensuring it meets functional and non-functional requirements. So we look into the system design, high-level design, low-level design, and tools and techniques. So this comprehensive design documents guiding the development team. Right. And for implementation, it translates the design into functional software among coding, integration, and testing. So it covered the coding, as I mentioned, the integration, focus on the modules to ensure that they work together as intended, the unit testing, and debugging. No? So, and when it comes to tools and techniques, integrated development environment, IDEs, no, version control system, and testing frameworks must consider. Okay, so ensures what will be the importance of design and implementation in software engineering. Ensure that software is scalable, maintainable, and aligned with user requirements, and it can minimize actually risk of costly errors of rework during the later stages of development. So this structured approach to design and implementation is a fundamental delivering quality software, no solutions. Okay, so that's it for this time.